Hi everyone, myself Dr. M. Lakshmi Prasad. Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about the brief overview on statistics. So in this video, I'm going to cover what should be the overview of statistics and what kind of data we are going to be inject into the statistics, and then critical thinking, and then how we're going to design of experiments we are going to see in this video. So when it comes to the statistics, so the common goal of surveys and other data what we're going to have, so it should be from the smaller part from the larger group, so that we can able to learn something about the larger group. So in this section we're going to look some of the ways of describing the data. So very first thing is that definition. So what should be a data? So data is nothing but an observation, such as measurements, or it may be a gender, or it may be a survey responses that have been collected. Okay, so the data may be and it may be an observation. So if I'm going to take any kind of application, so from that application, so by observing that we can able to extracting the data, or by seeing the picture also we can able to extract the data, or we can able to get the data from various sources like internal sources and then external sources. So, or it may be a measurement. So it may be supported by conducting an experiment. So can able to get some value. So that value should also be treated as a data, and then gender, some survey responses, uh, like that. So this and all will be considered as data that should be going to be collected here. And next one should be the statistics. So exactly what the statistics means that, so it may be a collection of methods for planning the experiments and then obtaining the data, and then we can able to organizing, summarizing, presenting, analyzing, interpreting, and drawing the conclusions based on the data. Okay, so the statistics may be a collection of methods that going to be used for planning the experiments and then obtaining the data, and where we can able to make the data should be organized, or can able to make it as a summarize the data, and then we can able to present the data by making use of some visualization tools. And once the data is going to be present, then we are going to be analyzing the data what it is and what better we are going to be analyze, and finally interpreting, and then finding, drawing the conclusions based on the data. So this should be the definition of the statistics here. So the statistic may be a collection of methods for planning and then experimenting and then obtaining the data. So once that thing is done, then have to be make use of organizing, then can able to summarize, and then can able to present, analyze, interpret also. So next one, in statistics we're going to see the term and the term what we called as a population here. So the population means that it should be a collection of all elements like scores and then people and measurements and so on to be studied. And the collection is to complete in the sense that it includes all the subjects to be studied. Okay, so the complete collection of all elements to be studied, and collection is to complete the sense that includes all the subjects to be studied, that should be treated as a population here. So the population means so which can able to complete collection of either it may be a people or it may be a measurement. So this collection is to be uh, include all the subject that is going to be studied, treated as a population here. And census is the another thing. So census is nothing but so the collection of data from every member of the population. So from the population, right? So the collection of data, so from that population, for every member of this population, so the extracting is nothing but census here. So extracting the collection of data from each and every member of the population will be treated as a census. And sample is nothing but the subcollection of elements drawn from the population. So from this population, So if I'm going to draw some of the samples of this, so that thing, some of the elements from population, then it should be treated as a sample here. Okay. So syntax means that, so it should be a collection of data from every member of the population, and sample means sub collection of elements that is going to be drawn from the population, that should be treated as a sample here. Then comes to types of data. So the data may be of different types. So before going to see this, we should somehow the basic terms that are going to be needed, that parameter. So parameter means a numerical measurement, so describing some of the characteristics of the population. Okay, so from the population, a numerical measurement, so which is going to be described some characteristics, okay, of the population, will be treated as a parameter here. Suppose in this population, all these elements is going to be have some parameter a1, otherwise it should be p1, and all the elements of the population, and this is going to have some other characteristics, so I'm going to consider it as p2. And this thing, I'm going to consider as p2. So the numerical measurement which is going to be describe the characteristic of population will be treated as a parameter. And what should be the statistic here? So statistic means it should be a numerical measurement which is going to be describe the characteristics of the sample. Okay, so once the population is done, so from that population, numerical measurement is going to be considered, so which is going to be described some characteristics of the sample. So from this population, I'm going to this sample, so which is going to be describe the characteristic of the sample will be done through the statistic. What should be this quantitative data? So normally the data will be of two types, I said previously. One is through quantitative data, and another is through qualitative data. So what is this qualitative and then quantitative data? So this quantitative data is going to be represent the counts, or it may be represent the measurements. Example, weights of some supermodels. So that should be treated as a quantitative. Otherwise, the height in centimeters and then weight in kgs. So this data will be of two types, like qualitative and quantitative. So the quantitative data is going to be have some measurements, and it should also going to be represent the counts also. And while qualitative data, so it should be a categorical data, or it should be an attribute data, so which can be separated into different categories, so that should be distinguished by some non-numeric characteristics. Okay, so example like gender, so gender means it should be male or female, there should not be any kind of measurements here. Okay, so the qualitative data is not going to have any measurements, so the data will be treated as a qualitative data. The other synonym of this qualitative data may be the categorical data, or not simply you can able to call it as attribute data. Normally this qualitative data is going to be separated into different categories, which should be distinguished by some non-numeric characteristics. So example, gender, male of the professional athletics. Next, working with the quantitative data. So normally this quantitative data can be further distinguished between two types, what we call as a discrete and then continuous data. So the quantitative data, which should be like qualitative data, right? So again, this qualitative data is going to be described into two characteristics, like quantitative discrete data and then continuous data. So what should be this discrete data and what should be this continuous data? So normally this discrete data is not going to be considered any time. So it should be linked with the time. Okay. So just while looking this quantitative data, the quantitative data is being further divided into two more categories. What I said is discrete one and then continuous one. So let's see the definition. What should be the discrete one? So discrete means discrete data is going to be result when the possible number of values uh, is either a finite number or it may be a countable number of possible values. So discrete means whenever the data is there, so that should be either finite number or maybe a countable number of possible values. And so example, so the number of eggs that hen lays. So let it be 12. So what should be this? This should be the count, right? So then this type of data will be considered as a discrete data. Okay, so discrete data means that so the data which is going to be result number of possible values that may be either a finite number or it may be a countable number of possible values. So examples, so the number of eggs that hen lays will be treated as a discrete data. And what should be this continuous data? So continuous data means it should be called as a numerical data, and this kind of data is going to be result from infinitely many possible values that should be corresponding to the continuous scale, which is going to be covers the range of values without gaps, interruptions, or jumps. So that means that the data which is going to be gathered with respect to time should also be treated as a continuous data. So numerical data able to result from infinitely many possible values that should correspond to some continuous scale, which is going to be covering the range of values. So without going to be gaps, interruptions, and jumps. So example like so the amount of milk that cow produces. So sometimes it may be 2.3 gallons per day. Should be on Monday, let it be, and 2.4 it should be on Tuesday, and 2.1 it should be on Wednesday, and 2.3.0 should be on Friday. So like this. So the what the data here, the data is going to be changed every day. So with respect to time, right? So this type of data should be considered as a continuous data. And next we are going to see what are the different levels of measurement here. So for that, there should be a way to classify the data. It should be used to different levels of measurement. Four of these levels are going to be discussed uh, in the following slides. So normally these levels of measurement should be categorized based on the data what we classified, and then measurement levels also going to be classified to the data what I'm going to be classified. So example like very first thing should be nominal level of the data, nominal level of measurement. So normally this one should be characterized by the data that consists of names and labels or categories. And the data cannot be arranged in ordering schemes such as low to high like this. So nominal level of measurement means this kind of data should be characterized that thing where we can should not ordering the data like low to high or following the order like A B C D and coordinate series and low medium. So low first, second, third. This kind of ordering is not followed by the nominal level of measurement. So it should be like names or labels and then categories. So where the data cannot be arranged in ordering scheme, that and all should be treated as a nominal data. Example like survey responses, yes or no, undecided. So the several responses means either it should be yes or no, like this other kind of measurement. This kind of data consists of names, labels, and categories only, where the data cannot be arranged in orders. And next one is ordinal level of measurement. So in this ordinal level of measurement, so the data is going to be arranged in some order, but differences between the data values uh, cannot be determined, or it should be meaningless. So ordinal level of measurements means it involves the data, so that should be arranged in some same order, but the differences between the data values cannot be either determined, or it should be meaningless. So example like course grades like A, B, C, D, F. So the data which is going to be arranged some order like A, B, C, D, and 1, 2, 3, 4 to 10, and then first, second, and then we're able to split low, and then medium, high, like this. This the data which is going to be arranged some particular order, that data should be treated as ordinal data, and it should be of ordinal level of measurements. So this ordinal level of measurements involves the data that should be arranged in same order, but the differences between the data values cannot be either determined, or it should be meaningless. And next one is that interval level of measurement. So what should be the interval level of measurement? So it should be almost all similar to the ordinal level, with the additional property that the difference between any two data values is meaningful. So however, there should not be any no natural zero starting point where none of the quantity is present. The years like 1000, 2000, and then 1776 and 1492. Okay, so this almost all similar to the ordinal level, but the additional property is that so there should be a difference between the two data values that should be meaningful, and there should not be non-zero or starting point here where the quantity is going to be presented. And next one is the ratio level of measurement. So in this level of measurement, so the interval level is going to be modified, which is going to be include some natural zero starting point, where zero indicates that it should be number of the quantities present. So for example, for values of this level should be the differences, or it should be a ratios, that should be the meaningful one. So like prices of college textbook should be uh, not be start with $0, so that should be no cost. Okay, so the ratio level data is going to be include some of the non natural 0 point, where the zero indicates that none of the quantity is going to be present. For example, the differences between the ratios or differences is going to be considered. So that thing will be treated as a ratio level of measurement. Let's see the summary of this. We should overview on the different levels of measurement like nominal. So nominal means categories only are going to be considered, and then ordinal means that so where the categories with some particular order is going to be considered. So interval means the differences but no natural starting point. So but here in ratio the differences is going to be considered, and is going to be have a natural starting point. So this should be the sum of these different levels of measurement here. So different level where the data should be different types like discrete and then continuous. So this thing becomes under quantitative, and then qualitative means data. Qualitative means it is not going to have any no measurements. Okay, so again this qualitative data is further divided into so many types, and quantitative data is also going to be further divided into so many types. So these are the things I would like to be discussed in this video. So very first thing is that, so data. So data means that it should be a observation, so such as it should be in the form of measurements or genders that should be going to be collected. And statistics means it is a collection of methods that is going to be used for planning the experiments and then obtaining the data. And what is the data we collected that should be in making the arrangement, or that should be treated as organizing, summarizing, presenting, analyzing, and interpreting. And so the populations, what should be that, it should be a collection of all elements, and it is to be studied. So the collection is to complete in the sense that should be also include all the subjects to be studied. And census means that, so we are going to have a population. So from that population, the collection of the data from each and every member of the population will be treated as a census. And sample means that, so from that population, if I'm going to gather some of the different elements, those should be the sample of that population. So these are the differences we should be identified here. So types of data. So before going to see this types of data, we're going to have parameters. So parameters means it should be a numerical measurement that is going to be describe the characteristic of the population. So the population, what is going to have different things like. So from that population, if I'm going to have different characteristics, suppose I'm going to construct an engineering college. From this engineering college, the students of CSC and students of AC and students of Triple. So these are not the population of this elements of this, and again in these elements I'm going to further divide it uh, like CSC people. So let it be P1 and then P2 and then P3 like this. So these are the parameters like this where can able to be extracted from the characteristic of the population. And next one is statistics. So statistics should also be numerical measurement for describing the characteristic of the sample. So this here, the statistic came into picture, so which is going to be describes the characteristics of this sample should be treated as a statistic here. And next one is quantitative data. So quantitative means, so where the data is going to be represented in the form of counts and measurements. Okay, that thing should be treated as a quantitative. And means the weights of supermodels like height in centimeters and weight in kgs like this. So this and all will be treated as a quantitative data. And then qualitative means, so it should be categorical data, it should not have any kind of measurements here. And again this data is going to be separated into further categories, uh, like suppose example gender. So gender may be male and female of the professional athletics. So while working with this quantitative data, so again this quantitative data is further divided into two types like discrete and continuous one. So discrete means where the data should not be related to time, whereas the continuous means the data should be related with the time. So discrete means that, so the data which is going to be result in finite number of, or it may be result in the countable number of possible values, then the thing should be treated as a discrete one. And continuous means that, so the data which is going to be gathered with respect to time, and which is going to be cover the range of values without any gaps or interruptions or jumps in between them, though that thing should be treated as a continuous one. So suppose in between the 2 and 3 I may going to have 2.1, 2.2 and 3, 2.6, 2.9 like this, where the data is going to be changed with respect to time. So example what I said should be amount of milk that cow produces. So one day it should be 2.3, and some other day the value may be changed, and some other day it should be 2.7 or 3 like this. So this and all will be treated as a continuous data. And once this one is done, then where uh, there should be different levels of measurement here. So normally you're going to have 4 levels of measurement, like nominal level of measurements. So where the data is going to be characterized based on the names, labels, and categories, and data cannot be arranged in ordering, then it should be treated as a nominal level. And ordinal means, so where the data is going to be arranged some order, and should be further divided then it should be treated as a ordinal one. And interval level, so interval level is also similar to the ordinal level only, but with the additional property what I'm going to be see in interval level is that, so the difference between any two data values should be meaningful. So however, there should not be any no natural 0 point state. An example like years, so year should not be start with 0, right? And then the no value is going to be start with 0, then it should be treated as a ordinal, internal interval level of measurement. And ratio level of measurements means, so here the data is going to be have 0 starting point. So where 0 indicates that should be none of the quantities present, and suppose the price of college textbooks like this. And if we look at the summary, then it should be nominal, where the categories is only to be considered, and ordinal means, so here we can able to consider the categories with some based on the ordinal. And interval means, so the differences but no natural starting point. And ratio means the differences should be considered and it should be going to be have natural starting point. Okay, so the first two things will be related to the data, qualitative data, and next two should be related to the qualitative data. So like this, we can able to have different levels of measurement terms. So okay, so in this video, I discussed some of the basic definitions and terms that is going to be used for describing the data, where what should be the difference between the parameters and then statistics, and what are the different types of data, and then different levels of measurement. So there should be a population. So from that population, we are going to be know the parameter based on the characteristics, and then from that characteristic, we are going to extract the parameter. And then statistic is that tool should be going to have different collection of methods which is going to be describe the characteristics of these parameters. And types of data, what I said, should be qualitative and quantitative. Again, this quantitative should be discrete and continuous, whereas the qualitative should be again different things where no measurements should be considered here. And different levels of measurements also I discussed, like ratio scale, interval, ordinal, like this.
Like, share and subscribe. Hit the bell icon for more updates.